All right. Good morning once again, and welcome to today's class. Okay, so please make sure you have your writing materials, a biro, and an exercise book, so that you'll be taking note of all what you'll be going to be studying today. So please make sure you are writing so that you can follow, because we are going to be making use of all the things we are going to be discussing here. So this is going to be like an introduction. After this, I'll be solving some examples, and then I'll be dropping it after these slides. Okay, so let's go to our topic for today, trigonometry. And please, if you can't hear well, you can use an earpiece so that you can listen very well and attentively. And please try to avoid distractions and look for a quiet place so that you can follow well. Okay, so we are going to look at trigonometry. Trigonometry 1. Okay, trigonometry 1, there is trigonometry 2, there is trigonometry 3, and so on like that. Okay, but for now, we want to start with trigonometry 1, that is the introduction. Okay, so from the content there we have trigonometry. We are going to see what trigonometry is, the meaning of trigonometry, and then we're also going to see trigonometrical ratios. That is, there are some ratios that they are used in trigonometry, so we're going to see them. And then thirdly, we are going to see complementary angles. Complementary angles. What are complementary angles? We are going to also see them. And then we are going to see Pythagoras theorem as well. Pythagoras theorem, I know you must have done Pythagoras theorem in your junior class, but we are still going to apply it here. Okay, we are still going to apply it. Again, we are going to see spatial angles. There are some angles, they are called spatial. They are called spatial angles. So we are going to see why are they called spatial and what are those spatial angles, and then application of spatial angles in solving triangles. Okay, so we are going to be applying these spatial angles, and then so that we can solve some problems in triangles. Okay, so next we have the meaning of trigonometry. So we have the meaning of trigonometry. Okay, so let me shift this here so that we can see them in together. Okay, so there we have trigonometry is a branch of mathematics that studies the relationship between sides and angles of triangles. Okay, so it's a branch of mathematics. It's an aspect of mathematics. Mathematics is divided into so many branches. You have algebra, you have geometry, you have trigonometry, you have statistics, and so on like that. So trigonometry is an aspect of mathematics. And what does it do? It studies the relationship between sides and angles of triangle. That means trigonometry specifically applies to triangles. Please take note. Trigonometry applies to triangles, while geometry applies to others. Like geometry applies to triangles, quadrilaterals, and others. So trigonometry applies to triangles. So the second paragraph, they say it was derived from two Greek words, trigonon, meaning triangle, and then metron, meaning to measure. So you can see there, the word trigonometry was gotten from two Greek words, trigonon, which means triangle, and then metron, which means to measure. So if you combine them together, that means the measurement of triangles. So you call it trigonometry. Okay, so if I come back to this point, if you look at the diagrams there, basic trigonometry terminologies, you have the triangle there. Triangle is a polygon with three sides and three angles. Even though there are so many types of triangle, we have isosceles triangle, equilateral, right angle triangle, and so on. Okay, but we know a triangle has three sides. It also has three angles. So you see there, you have side, side, side. You have angle, angle, angle. Sum of three angles is 180. That one, they are just basic trigonometry laws. We're still going to be looking at those. You have the right angle triangle there. So longest side is called hypotenuse. Okay, so we are going to be looking at that, but this is just basic terminologies of the trigonometry. You have angle, you have the side, and then of the angles and the different types of triangles. So that is that. So we say trigonometry is the study of sides and angles. Okay, so it's just showing relationship, just a relationship between sides of a triangle and the angles in the triangle, how they are related. How are they related? So we are going to be seeing that. We are going to be seeing that. Okay, so next here we have trigonometrical ratios. Trigonometrical ratios. So what are these trigonometrical ratios? Remember, we say trigonometry is the study of sides and angles of triangles. So what are these trigonometrical ratios? They are ratios that they are used. Remember, we said trigonometry shows relationship or studies relationship between a side of a triangle and then the angle. Okay, it shows the relationship between the side of a triangle and then the angle. So these ratios that we have here, they give us the relationship. They show us how we can relate the side of a triangle and then the angle, how we can relate them together, how we can relate. So if you carry any triangle, specifically right angle triangle, you the side of that triangle and then the angles, they are related. So we are going to be seeing that. And please take note, trigonometry, we are going to strictly be using right angles triangles. Okay, trigonometry, we are going to be using right angle triangle, right angle triangle. Okay, so the basic trigonometrical ratios are sine, which can be seen, which is mostly used sine, sine, and then the cosine, cos, that's the cos, and then you have tangent, that is tan, mostly called tan. Okay, you can have other trigonometrical ratios like secant, they call it sec. Okay, you can have cosecant, which is called cosec, and then you have the cotangent, which is called the cot. Okay, but basically the ones we are going to be using are sine, cosine, and tangent. Okay, these three: sine, cosine, and tangents. Okay, so these are the basic ones we are going to be using. So let's see how they are related. Okay, so trigonometrical ratios. Um, this is how they are related. Now, this is how they are related. Okay, trigonometric ratios. These are the related. So you can see them. You have the sine, you have the cos, you have tan, sec, cosec, and then the cot. So there we have a right angle triangle. Look at it there. This red line is called the hypotenuse. Okay. Let me use this one. Okay, this side is called the hypotenuse. That's the longest side. I mean this side. This is your hypotenuse, which is the longest side. Any longest side. Remember, I told you we are going to strictly be adhering to right angle triangles only. So there you have the right angle. So the longest side, which is that red line, is called hypotenuse, while this guy here, the blue side, is called the opposites. Okay, the opposites is called the opposites. That is the side that is oppositing your angle. This is your angle theta. This is your angle here, theta. So any side that is oppositing the angle theta is called opposite. And then this guy here, the green line, is called adjacent. Okay, adjacent is the line that if you look at your this is the right angle, this is your right angle here, and the angle theta, okay, they are on a same line, they fall on the same line. If you look, all of them are on the same green line. Okay, they fall under the same green line. So any line that your right angle and then the theta falls on, that side is called adjacent. Okay, that side is called adjacent. So whenever you see your right angle falls on a line and then the angle theta also falls on a particular line, that line is called the adjacent. adjacent. And if you look the angle, your angle is oppositing the hypotenuse, while this side that is oppositing the theta is called the opposite. It's called the opposite. Okay, so this is how this, so hypotenuse, opposite, and adjacent, they are sides of a triangle. They are all sides of a triangle. They are all sides of a triangle. So the angle there is theta. So how is theta related to these three things? Or how is theta related to hypotenuse? How is it related to opposite? How is it related to adjacent? So if you check here, first and foremost, you have so, they call it so. This first one here. So, okay, they have a acronym, they call them so katua. So the so, look at the ka and then the toa. So katua. So that so there is S means sine, the O there is opposite, the H there is hypotenuse. So look at it, sine theta is equal to opposite all over hypotenuse. Opposite all over hypotenuse. The S there is sine, the O is opposite, the H is hypotenuse. While the K, which is cos, now the C is cosine, the A is adjacent, the H there is hypotenuse. And then you have the tan. The tan, toa. The T is tan, the O is opposite, the A is adjacent. Okay, so if you are given any two sides in a right angle triangle, any two sides at all, you can find the angle. If you are given opposite and hypotenuse, of course you know you are going to use sine. If you are given adjacent and hypotenuse, you are going to find cos. If you are given opposite and adjacent, of course you know is your tan. So this is the relationship between the sides of the right angle triangle and then the angle. Okay, so the SOHCAHTOA, that is sine, cos, and tan, they are the ones that are relating the angle to the side of a right angle triangle. Okay, and we can see these other ones here. These other ones we talked about. These other ones we talked about here. These other ones we talked about here. They're here. Look at them here. Okay, that's the cosec, the sec, and the cotangent. Okay, cosec is just 1 over sine. Okay, when you have sine of an angle, when you take the inverse of the sine, you have cosec, and then sec is the inverse of cos, and then tan is the inverse of cot. So it's just inverse. So when you take the inverse of the tangent of an angle, you have cotangent. When you take the inverse of the cos of an angle, you have sec, that is secant. When you take the inverse of the sine of an angle, you have cosecant or the cosec. Okay, so these are the basic trigonometric ratios, but for this class we are going to be using the SOHCAHTOA. SOHCAHTOA, that is sine, cos, and tan. Sine opposite over hypotenuse, cos adjacent over hypotenuse, toa opposite over adjacent. So even if you are given an angle, even if you are given theta, and then you are given one side of the right angle triangle, you can look for the other side by the use of these trigonometrical ratios. Okay, so I'm going to be solving some examples, and then we are going to be seeing how we are going to be using this trigonometrical. So this is an introduction. I'm going to be solving some examples, and then so that we can see for ourselves. Okay, so the next thing there we have is complementary angles. Okay, complementary angles. So what are complementary angles? Complementary angles are two angles whose sum is a right angle, that is 90 degrees. 90 degrees. So when we say angles are complementary, what I mean is if you add these two angles, they will give you 90. That's just it. If you add these two angles, they should give you 90. And if you add them, they give you 90. Those two angles are said to be complementary. For example, there I said if A plus B is equal to 90. Okay, here it said if a plus b is equal to 90, a and b are said to be complementary. That is, if you add angle A and angle B, if you add them together and they give you 90, A and B are said to be complementary. And I give some other examples there. Examples are 70 and 20. 70 plus 20 gives you 90. 45 and 45. 45 plus 45 gives you 90. 60 and 30. 60 plus 30 gives you 90. And so many others. So 70 and 20 are said to be complementary. 45 and 45 are said to be complementary. 60 and 30 are said to be complementary. So any two angles that you add them and they give you 90, they are said to be complementary. Complementary angles. Complementary angles. So we are going to be using them. We are going to be using them. Okay. So please note the following. Note the following, please. Very important. I said note the following. Please look at them. Very, very important. Okay. Now I said 90 minus alpha and alpha are complementary. Remember we said complementary angles, when you sum them they will give you 90. So I said 90 minus alpha is an angle, and then alpha, they are complementary. Why? Because if you add 90 minus alpha plus alpha, it will give you 90. It will give you 90. Okay, look at it here. 90 minus alpha plus alpha is equal to 90. Why? Because minus alpha plus alpha is 0. Okay, minus alpha plus alpha is 0. So you have 90 there. So 90 minus alpha and alpha is equal to 90. All they are said to be complementary. Therefore, cos alpha is equal to sine 90 minus alpha, and sine alpha is equal to cos 90 minus alpha. Please take note, we are going to be using this rule. This is very, very important. Please take note of this rule. We are going to be using them. We are going to be using them. This rule, very, very important. Please take note of them. Remember what I said here. 90 minus alpha and alpha are complementary. 90 minus alpha and alpha are complementary. Therefore, cos alpha is equal to sine 90 minus alpha, and sine alpha is equal to cos 90 minus alpha. Okay, so please take note of that. We are going to be using that. Remember, cos, we said cos is adjacent over hypotenuse, sine opposite over hypotenuse. Okay, so I'm going to be solving some examples. So please make sure you are writing, and make sure you take notes. And then if you have any question, you can drop as we continue the class. Okay, so thank you very much for listening, and look forward for the examples.